Hello everyone, welcome to the solution of LeetCode problem 55 named Jump Game. In this problem, we are given an integer array. Suppose currently we are positions in the first index of this input array. Now, each element of this array represents the maximum jump length we can do. And we have to return true if we can reach the last index by using the jump, or false otherwise. In the first example, the array contains 5 elements, which is 2, 3, 1, 1, and 4. Here, currently we are presented in this index. The value is 2. That means from the first index, we can jump at most 2 steps. Now suppose from the index 1, if we jump length 1, then we will reach to the second index. Now, from the second index, we can jump 3 steps. That means we can reach to the last index 4. So here we have to return true. Now in the second example, it is never be possible for a person to reach to the last index by using the jump, because if someone jumps 1, 2, or 3 steps respectively, then he will end up to this 0 cell. From this 0 cell, he will not jump to the last position. So here we have to return false. I hope you understood the problem statement. Now the constraint are here. The array length can be in between 1 to 10 to the power 4, and each of the array element can be in between 0 to 10 to the power 5. I hope you understood the constraint. Now let's move on to the algorithm. Now, for the simplicity of the algorithm, we have taken the first example. Here, the first example consists of 5 elements, which is 2, 3, 1, 1, and 4. And currently, we are presented here. So from this cell, we can jump at most 2 steps. So here, either I can jump to this cell 3, or I can jump to this cell 1. Now, we can jump 1 step and reach to the cell 3. Now from cell 3, we can jump either 0 step, 1 step, 2 step, or 3 step. So from here, if we jump 3 step, we can reach to the final destination. So that's why in this problem, or in this test case, we have to return true. Now, this is the index number, and the index number starts from 0 for the array or the vector. So the index number is 0, 1, 2, 3, 4. Now, the problem is currently at first we are presented in the first index, and we have to reach to the last index here. But we will analyze this problem in a reverse order. We will solve the problem in such a manner that currently we are presented at the last index, and we will try to reach to the first index. If currently starting from the last index, we will able to reach the first index here, then in this case we will return true. Otherwise, we will return false. Now, our algorithm is, for each iteration from the backwards, we will check the value of a of I plus I is greater than is equal to goal or not. If it is, then we have to update our goal to Y. Anyways, suppose currently we are presented at this last index. So here, the value of I plus AI, that means 4 plus 4 will be 8. And initially, the value of goal will be 4. So we can say that 8 is obviously greater than 4. So currently our value of the goal is 4. That means we can reach these positions if we start jumping from these positions also. Now we are at these positions. Here the summation of ai and I will be 3 plus 1, which is 4. So 4 is greater than is equal to the goal. So that's why we have to update our goal. Now our goal will be 3. That means we have reached these positions, or if we start jumping from these positions, we can reach to the final positions. Now, currently we are at these positions. For these positions, the value of ai plus I will be 2 plus 1, 3. So we can say that 3 obviously greater than or equal to current goal 3. So here we have to update our current goal, which is 2. That means if we start jumping from these positions, we can reach to the final positions. Now, currently we are at these positions. Now the summation is 3 plus 1, which is 4, which is obviously greater than is equal to 2, which is the current goal. That means in this case, we have to update our value from 2 to 1 for the goal. That means if we start jumping from these positions, we can reach to the final positions. Now we are at the first positions. Here the summation of 0 plus 2 will be 2, which is greater than 1. That means we have to update the value of goal from 1 to 0, which is this. That means if we start jumping from these positions, we can reach to the final positions. Now we have completed the iteration. Now we will check whether the value of the goal is 0 or not. So we can see that the value of the goal is 0. So here we have to return true. So this is the basic algorithm to solve this problem. Instead going to the left to right, we will move to the right to left. I hope you understood the algorithm. Now let's move on to the code. In this code, there are function given named canJump. The parameter of this function is the input vector. Now currently n is the size of the input vector and our current goal is n minus 1. Now we are using a for loop from backward directions from n minus I to 0. And inside each step, we will check whether the summation of I and a of I is greater than is equal to goal or not. If it is, we have to update our goal. And finally, if the goal value is 0, then we have to return true. Otherwise, we have to return false. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n. Because we are iterating through every element of the array. So in the worst case, the time complexity is big O of n, where n is the size of the input vector. And the space complexity is big O of 1, because we are using only constant extra memories to solve this problem. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.